गुड इवनिंग एवरीवन। तो आज हम करेंगे रिवर्सिंग। तो शुरू करने से पहले लेट्स हैव सम introduction about reversing, what actually reversing is, how do we do it, and what's the actual approach of it. So let's say I have a C file named as program.c. It is compiled and output is, let's say, crack me. So what this program file will have, it will have the code, whereas this will be just a binary, or you can say executable. And here you do not have any information about source code, no source code info. And our main motive is to understand the binary or executable, how it works, and how to bypass some security checks. Sorry for that. So before that, one more, directly jumping into the practicals, some information about the binaries. Okay, so binaries, okay, let me show you by, so I have a binary over here named as just C. To know about any file, we usually use file command, file space the file name, and just hit enter. Here you can see the information about the executable is given. Okay, it says elf file 64-bit executable, 64-bit it is, and dynamically linked. What this dynamically linked means, so let's say while I was compiling this program, every program, C program has some headers file. Okay, and they need some libraries to run. So while compiling, if I am adding libraries, then it will be statically linked. Okay, otherwise I will the program will be compiled in such a way that it will use the libraries of your system. Okay, then it will be called as dynamically linked. Uses the running system's library, and usually library linked files are of less size and statically are of more size. And it's pretty obvious, because the libraries are added into the static linked files, so size would be more. Okay, so about interpreter, lib64, and hash, and okay, here it is stripped and non-stripped. So what non-stripped and stripped means? So let's say this program.c have two functions. First one is test1 and another one is main. Okay, so if it is non-stripped, I would be directly able to see the name of the function as main and test1, whereas in stripped I will not be able to see the original name. I will not be able to find directly that it is main function. Obviously main will be there, but the naming and the nomenclature will be different. It can be of name of func 0, 7, blah, any random which you cannot guess, okay, that it is main or it is test. Func 0 and just some random words. So this is stripped and non-stripped. So tools which we will be using are the basic before like understanding the, you can say, binary executable, there are some basic things which we should do initially on any of the file. Strings and of course file command. These two will help us to, like, before opening the file or running the file, it will kind of give us an idea, okay, what the file is having and what it will do. Okay, so here you can two commands, file and strings. On that executable file you have to do just like prior reconnaissance or prior information. Then we will be using Gdb. It is GNOME debugger, and we will be using PEDA version. Not paid, it's PEDA. And another we will be using Ghidra and Radar 2. So what my approach basically is, while solving a reversing challenge, I not depend only on any one of the particular tool. I use all of the tool to understand or to have better knowledge about the binary. Like Radar 2 helps me with the flow chart, like how the executable or how the binary will be working or executing, like which function will go, like all the like flow diagram. Let me show you. Radar. Okay, just to install it, sudo apt install Radar 2 and hit enter. In mine it is already installed. So just type Radar 2 /, just to run any of the file, any executable file. First you have to check its permission, whether it is having executable permission or not. To check it, ls -l. So here we can see it is having X in each of the group permission, group owner and user permissions. Okay, and if it would not have that permission, we would use chmod space +X and just the file name and hit enter. So /, just C, check flag or just give the input like random, and it says bad. Okay, let's do strings on it first. Strings and just C. So it gives us an idea. Okay, give me hello, give me your flag, check flag, good and bad. So okay, I can understand over just by seeing these 5 lines that okay, it will be having a first prompt or first line which will be printed as hello. It will ask for flag and I will give the input over here, and if it is correct it will print good, else it will print bad. And here we can see something fishy like flag E4 SH and like this. So here you can have, let's try this. Okay, /, just C. Sorry, it was, sorry, I just forgot. Now let's try this. /, just C. It's bad. Okay, we will look into it later. So now look, just we will be looking this file using Radar 2. Radar 2 / just C. Okay, now what here we will be doing, to analyze any of the binary file in radar, there are options. Initially we have to press over here like AA, triple A and 4 times A. So each command or each particular sets of A has its different functionality. AA will give me some information, triple A will give some more information, and 4 times A will give some more information. So let's use 4 times A, hit enter. Now the binary is loaded to in the analysis form. Now we will be disassembling the main function. Okay, and how I can see there is a main function using Gdb. I will go to the Gdb later on, but just assume that there is main function because it is a non-stripped binary, and C programs usually have main function. Okay, so S space main, write S and any of the function name which you have to disassemble. S space function name. Our function name here is main, hit enter. So our main function is disassembled in the backend, capital V twice. For the visual, you can say flowchart, hit enter, and here we are greeted with proper, you can say flowchart. You can see comparisons, test. Okay, if it is true then it will go over here. Using the arrow key you can access it. Using command cursor it will not be accessible. Just use the arrow key, up key, down key, left, right. Okay, now just here we can have a pretty good idea. Okay, it is asking for flag, check flag. It will this is our, you can say, assembly language. So using this you can have a pretty good idea. Like it is just a short binary, or I can say it is a very small program. So whenever you are having a complex program with nested if and else, so at that time you will be have a pretty good idea. Okay, how the program is executing, what is the actual flow of it. See, here we are having, okay, check flag, it printf, it will be printing this, then it will be taking input. Like we can, it is pretty obvious, like scanf it used to take the input. Now here you can see move something, like if I'm like just you can say a beginner, I will be just I can have a pretty idea what is happening actually here. Like here it is move something ABS, so I can have an idea, okay, that something is moving into something. So here what the actual, you can say, execution of assembly language is, the right side, this one will be moved to this. Okay, this whatever it is, it will be moved into RAX. In this one, whatever in the RAX will be moved into this, and accordingly this works. So it looks like hex because it starts with 0x. So let's just try to hex decode it. Go online, hex decode. Okay. Okay. And then we have this. So let's add it together, because here you can see they both are being like RAX is having this also, and after that this is added into it. So if you are good at observing, you can see it. It is the reverse of something. Echo this REV. Boom. We have the flag. Let's try this. Flag easy char. / just see, paste, enter, and it says good. Okay. Another thing when usually the comparisons are being made into a binary, like here ltrace. Whenever you see any type of comparison over there, so directly or simply I can state into a statement like, whenever you are asked any input, try giving the input using ltrace if it is a non-step binary. Just see and random. Okay, so here you can see string comparison is done with our input with the actual flag, and then it is giving us bad. So here you can understand, or you can find out what the flag is. So this was the first, you can say, challenge or first program which we were working. So this helped you to understand the working of radar 2. Okay, radar 2, let's see once again. S main VV, hit enter. Now if I press V again, see there are all these functions. Or let me start again. S main VV. You are having this, like you are directly entered into the main functions flowchart. If you wanted to just take a step back and look all the functions which are present, just press V once, V and C. The star sign, it shows where you are currently. See, we are at the entry. Then likewise this, you can analyze any of the function. If you want to exit, just press Q, 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 enter. So this was about our radar 2. Okay, now look what GDB is. To install GDB first, simple GDB, not GDB pada. Like if I just type here GDB, you can see minus GDB pada. Okay, Control D to exit. To install GDB, sudo apt install GDB. Hit enter, and you will be your GDB will be installed. Now to change its flavor or just to add more functionality, I am using GDB pada. Just search GDB pada, hit enter, and this is the one, Python exploit development assistant for GDB. It has some extra features which we will be seeing in buffer overflows. Okay, to add this, just select your URL and git clone, paste your URL, hit enter. It will be cloned, it will be like downloaded. So after download, just move into that directory and cat readme. Here you can see how to install it. Okay, this is this. Okay, this line will help. See, so my pada is installed where? Home iRock tool pada. So use this in place of this. Wherever your pada is downloaded, just write pwd to find the current path and replace the only this much with this. Okay, like, and execute this whole function. So afterwards you will be greeted with GD pada. So there is one program named as KeyGenMe. Let's try some basic information gathering about it. File KeyGenMe Okay, 64-bit dynamically linked, not stripped. Fine. Strings, keygen me. Okay, here you can see it is asking enter your key. Good job, mate. Go on, blah blah blah. If it is correct, and if it is wrong, it will give us no. And down here you can see main and something called validate key. These are the functions which are present in our binary. Now, how to use Gdb? Gdb / your file name. Hit enter. So, first thing you have to do before analyzing any binary file is just change the assembly language type, not type, display type. Okay, set this assembly flavor Intel. Hit enter. Okay, it will just change the flavor into Intel and disassemble main. Here you can see, okay, printf. Let's see side by side. So okay, printf will print this. Done. Then it will be asking for input. Then okay, scanf is there to ask for input. Input is given. Then it is calling the validate key function. Then it is comparing EAX with 0, 1. If it is valid, it will move to this. Otherwise, it will move to other one. So okay, what JNE is? Let's search about it. JNE in assembly language. The JNZ or JNE instruction is a conditional jump that follows a test. Okay, it jumps to the specified location if 0 flag is clear to 0. Or okay, commonly used to explicitly test for something not being equal to 0. Okay, whereas JNE is commonly found after the comparison instruction. Jump if not equal to 0. So, string compare, if you are pretty good in your C or C++ concepts, so string compares, whenever you use a string compare, you can say instruction, then the output is usually in 0 or 1 format. Okay, like if it is true, it will print 0, it is false, it will print 1, likewise whatever it is. So compare is there. If it is 0, then accordingly it will be functioning. So clearly, if my original key is correct, then it will print good job, keygen me, and if it is wrong, it will print no. So let's see what this validate key function has inside. Like we are disassembling main here, now disassemble validate key. Okay, it is doing something over here and it is returning something. Okay, fine. Now we can pause the executable file while it is running. We call it as breakpoints. Okay, so B main, it will mark a checkpoint or breakpoint at the main functions. Like whenever the execution reaches at main function, it will stop over there. We can analyze things, we can manipulate things, and then we can proceed ahead. So run C breakpoint 1. So currently now we are inside the main function. See, main function is loaded and currently we are at this point. Okay, now this If I just simply continue it by C, it will ask for input and it will give nope. So let's disassemble, run it again. Disassemble main. Let's try to fool the program. Like whatever the input is given, it will mark it as correct. Here you can see, if we can change the output of this, like if we are giving the wrong input, surely the comparison will give it false. Like, okay, the input which you have given is not matching with the actual, you can say, key, then I am giving the output as false. And likewise, it will jump and print this one. Okay. Jump if not equal to 0. Like if it is not true, then jump to main plus 98. 98 is this one. And it will then call puttest and it will give us nope. Okay. So, if there is possibility, like if we can manipulate the output of this, like if we can change the false to true, like okay, whatever input we give, this will give us 0 and it will execute this instruction, not bypass this and you can print this one. It will actually print this one. So let's stop at this point. You can save the copy the address of this B star. Like whenever you are giving any address, use star in front of it, and whenever you are using any function name, no need to use star. Hit enter and see breakpoint to at this. Hit C for continue. Enter your key, random key. Hit enter and see it is not giving any output. It is stopped at this. See the arrow points over here. See, EAX is compared with 01. So what is inside EAX? Okay, what actually EAX is? EAX is the register. Info registers is the command to see the you can say values inside the whatever register are present. Like if I say there are 10 registers, so what values or what things is present inside those registers at this point. When I am at this instruction, what value is present at that point? To know that, we have to reach the instruction breakpoint first, and then after reaching that, we have to use this command info registers. Hit enter, and here you can see RAX. RAX is equal to 0. So 0 is compared with 0, 1. Like 0x1 is 1, 0x0 is 0. So definitely if 0 is not equal to 1, so it will give us false. What if we change the value of RAX here, and if we put it equal to 1, then definitely 0 is not equal to 1, but 1 is equal to 1. Then it should print like good job. Here it was printing no. So to manipulate or to play with registers or to change the value of registers, we use set space $sign name of register. Set $RAX equal to whatever value we want. I want it to be 0x1. See, currently the value is 0. After this, again we see the value is now 1. See, 0, here 1. Now to continue, like just to proceed the normal flow, hit C and see, it prints good job mate and whatever after that. So this is a another method to bypass any of the comparison or any of the security check which is present in the binary. one more thing that we can do, if we wanted to, like, you will not have this scenario exactly, but I will tell you what other thing I could have done in any other, another binary. Just I'm telling you the approach. So we are having a call functions. Okay. So what if when this call function is called, instead of giving it this, address, I will give it this address. So instead of going to validate key function, it will go to this and print our desired output. This can be a possibility. So in actual, real world or any challenge, you have to go through a direct bypass, like we have a call function and some very complex comparison. No comparison is there, but it is taking input and then checking it, or okay, forget everything. Call is there, some complex instructions are there, and you see there is another function named as print flag. Another function is print flag, and you have its address. Okay. So why to go to this like whole crap when we can directly go to print flag? Okay. But only condition, the input which we are giving should not be in direct, the flag should not be depending on our input. Let's say there is a C program. What it does, it takes the input and it converts it into flag. What flag? Like it adds 1 into its ASCII code and then it gives out the flag. So here you cannot directly just jump upon to that print function, because here you have to give input, some processing is being done on that input, and then you are getting the flag. So if you directly jump upon that print flag function, then there is a possibility that you may or may not have your actual flag. So how to bypass that? Input validate key. Okay. So if I wanted to call something at here, so first I have to stop over here. Copy the function b star enter. Breakpoint is there. Okay, just remove. Sorry. Here we are having 3 breakpoints. First one is main, second one is this comparison, and third one is this. So in the normal execution, it may be possible that we may stop at this. So to remove our breakpoints, just write del. Okay. Now continue C. If I run, enter key, random, no breakpoints. So break main. Now it will be in ascending order, but this is our first breakpoint actually. But name 4 is given. So run, breakpoint done, disassemble main, and now we have to stop at this b star. Okay, so now we'll be stopping at this point, and what the address of our call function is this. like eventually I wanted this to be happening, like this should be executed anyhow if I wanted to succeed or if I wanted to get my desired output. So that is over at this address. So okay, currently we are at validate key. Okay, so info registers. Here there are some registers and some values there in it. So the instructions, this address, these are being fed into RIP, instruction pointers. So if like currently we are over here, so it is having the address of this. So let's try RIP equal to this. I'm not sure it will work or not, but let's try. Continue. Continue. Finish. No, it's giving the error. Look about this, okay, segmentation fault is there. It is not possible over here. But yes, this is a method also. Like RIP has the instruction, just change its instruction, so it will take the next step and it will move to that one. So this was our program 1. How much time? So moving to next one. CD proc 2. Okay. So first thing first, file CNM, shared object, dynamically linked, stripped. Okay. So here we are having stripped binary. That means we will, okay, let's see. Strings also, CNM, it enter key, good key, wrong key. Okay, I can have an understanding like it is asking for key, and apparently depending on the key it will just tell whether it is correct or not. Let's jump into Gdb directly. Set disassembly flavor intel and disassemble main. See, no symbol table is loaded. Why? Because we do not have main function here. Info functions. See, like in Gdb, to know about the function which are present over there, you can use this info functions command. We cannot see any of the main function or any other function apart from these standard functions. Okay, system calls. So Gdb will not help us here. So what will help here? So now we will be trying Ghidra. Ghidra is like, okay, radar 2 done. Gdb helps in manipulate things and this is Gdb. Ghidra, what it helps, it have the capability of Gdb in it with another functionality like pseudo code. It will try to analyze the assembly language and accordingly it will form a pseudo code. It can be exact code like exactly same as the source code, or it may not be, but the processing you will be able to understand using it. Okay, that this function how like a dummy code not exactly source code, but a dummy code of the binary, which will be similar to our source code, not exact to our source code. Okay. So to install Ghidra, as I told you, I have given you the link. Just download this zip file, and you need some dependencies. Sudo apt install open jdk 11 you have to install these: open jdk 11 headless and jre headless. jdk headless, hit enter, password, mine is already installed, and you may also need jre headless installed. Then cd tools. Okay, so this is your zip file. After unzipping it using unzip and using this command, just hit enter, and you will get this Ghidra folder here. And just if you have installed the dependencies, you are good to go. This is the file ./Ghidra run. Hit enter. Close this. So I have already used Ghidra. So first you have to create a new project. Then when you created the project, come in this panel, hit I to import the binary file. CNM, I already imported it. Okay, it will, let me remove it, delete, I, press I, then file is CNM. It will ask to import, okay, then okay, let's double click over it. Would you like to analyze? Yes, definitely. Analyze. Yeah, it is done. So this is your Ghidra. Here you are having your assembly language, assembly codes. Here you will be having decompled or pseudocode of the function, and functions are over here. So you remember this was a stripped binary, and see, as I told, you will not have any main or direct names of the function as it was in the original one. So how can I know from where the program is starting? Entry point. Click on the entry point. Okay, here you can see pseudocode. Why it is called pseudocode? Because it may have different nomenclatures, like different variable names or something like that. Okay, so first I can see, okay, it will start with this function ending with 1199, this function. Okay, just click on the function here and you will get your binary here, or not binary, pseudocode over here. Okay, so here you can see it is initializing some variables, taking the input string comparison. Okay, that means there is string comparison. It may have some then okay, let's try to run that binary actually. /cnn, enter key, wrong key. Okay, so I told you ltrace whenever we are having any input thing. Lol. Okay, so here you can see string is being compared with this dot slash cnm. Copy it. Just let me copy this cnm again, because I know there would be an error. Okay, we have cnm over here also. cd program 2. Now let's run this. It asks for key dot slash cnm. Okay, nothing. Wrong key. So again, let's use ltrace to make sure I have copied the correct thing. Okay, it needs, I guess, some more input. So move to Gidra. Okay, yes. Scanf and another scanf. See, if string comparison is this. Okay. Oh, okay. See. Initially it is string comparing are this dot slash cnm. String length is 4. See. Compared it. It will, if it is equal to 0, then this will be executed. See, good key is here and bad key is below it. Okay. So it is taking the input and it is saved in local 74 variable. Okay, so if this is equal to 1, okay, that means first input is 1. Okay, then another input, and it is comparing local 74 equal to 7. That means it should be 7. Another input, it should be 8. Okay, likewise, how many input? 1 and 2 more left. First is 8, second is 5. 8 and 5. Boom. So see, this is how Gidra helps you. It gives you pretty decompiled code or pseudo code to you to understand how the binary would have been looking with source code. Okay, the procedure or all the processes are present over here. So this was about the Gidra. So cd pro 3. So there is another file. Let's try to do that. Crack me, not stripped, dynamically linked. Okay, strings, crack me. So here you can see a very okay, initially it asks for the password, login, and successful and failed. Okay, and very complex strings are given over here. Let me find where is that. Okay, there is something called as reverse, and there is one more. Where it is? Okay, here, check password. Okay, so dot slash crack me, enter the password, blah blah blah, login failed as expected, ltrace over it, dot slash crack me, random, and we do not have any sort of comparison over here. Even if there would have been a comparison, we are not able to get it. So let's try with radar 2. Crack me, as main, vv, enter the password, this, check password, login failed, and correct. Okay, shit, where we are right now. See here, what here will okay, there is our Like currently we are over here. Now we have to move to check password. Check password. Okay. Let's try in Gdb. It would be more easy for us to see. Analyze, yes. Analyze. Functions. Main is there. Main, okay. See how beautiful here it is. Like very, less crap is present over here. We can pretty, good. We are able to understand from this. Okay, basic strings, enter the password. Then this is called, okay, check password. And one more good thing about this Gdb is, like, if you hover your cursor over to anything, any register or variable, it will just give more info about that. Let's check password. Okay, basic string. Okay, like whenever I am getting any kind of input, or whenever there is any comparison, I just hover my cursor over that there and see. Okay, 0x60 is called 96 and decimals, and this is like this. It will help you. So we saw check function, check password here. This is a bit complex one, by the way. So what it is doing over here, check password, allocate, basic string is called, which will allocate whatever is present at this. Double click on this and it says at this address or whatever function it is, we are having this DEC in it. Okay, and then variable is set to -7, then length again. If this variable is equal to minus of local 20 is -7, that means minus plus, so L variable should be 7. Then I can get a hint from this that my password length or whatever the key is, okay, password length should be equal to 7. Then this is initialized while loop is called. Local 24, length of this, how much we are having? 3 minus 1 is 2. That means it will iterate twice. Okay, we will have DE from this, and operator will add K. Afterward, it will add CAR in it. Fine. And at the end, it will add local 40 basic, okay, local 40, add this. Okay, so what it is actually doing, DC is there, okay, in this DC is over there, so it is taking the two part, like initially two characters of it. Here you can see local -1, like local 24 is of 3 length and -1 is, so it will be equal to 2. So 2 characters are taken from this. Okay, that's DE, and then these two, like operator plus equal to, these two are added in it. K is added, then CAR is added, and at the end operator plus local 60, like, and no, this is being added. Character which is left at this is added into our operator. And which one was left? D was taken, C is left, and then C. 1, 2, 3, 4, 5, 6, 7. Okay. This seems to be our password. Let's try this. / crack me and the password. Okay. Maybe some another checks are there. So if you remembered, like when we did the strings on it, strings crack me, we had a reverse with us. So, like, I already solved this earlier and had have some experience with reversing. So echo makes sense, cracked. Let's try with this / and it says login successful. So I will not assure, or I cannot guarantee that after seeing this video you will be directly able to solve the challenges and all. It comes by experience, by the way. No, the more you solve the challenges, the more approaches you will come to know, and the more approaches you will know, more possibility of getting the solved challenge will be there. There is one more challenge with me. / first one, file not stripped, dynamically linked, run strings. This main is there, some usage is also there. Okay, usage shows this, OTP is like this. Try again, nice job, flag. Okay, good to go. / it says that we have to use it like this, / reverse along with some password with this / reverse and pass. Okay, it says try again. Let's try with regard to / AAS main VV. Okay. So we have to get this. We have to get like this is our motive. So it is coming from here and this is from here. Fine. So some comparison is there. Compare AL with 0x40. What 0x40 is? Python 0x40, it is 64. Care of 0x40 is, it is @ okay. So something is being compared with the character @ like that gives me a hint. @ should be present in my password, but where, that we have to find out. Compare RAX is here. What 0A is? 0xa is 10. Okay, probably might be the length of the password, or key. So okay, it 2 is the argument. how we are executing it. / of file and some password. So number of arguments are 2. Like this itself is an argument and this is also an argument. So 2 arguments are given. If given yes, then it will go to this, otherwise it will show the usage. Okay, fine. Here it is comparing the length. Length is 10. Then it is going at here, otherwise it is printing usage. What here it is doing, move RAX keyword local 10H. So whatever input we have given, it is in this and it is stored into RAX. Okay, and then 8 is added into RAX. That like pointer is incremented by RAX, so it should be pointing in memory now. And whatever is in RAX word, so inside RAX we have a password, and in that password, then with that password is moved into RAX register, and then 4 is added to it. Like 4 is added to indexed. So what is happening over here? Password is given. Password is, let's say 10 character length, 0 1 2 3 4 5 10 length. Password is given. It is saved in memory, and 8 is added. Pointer of our password is stored into this, and then pointer is incremented by it, so that it will now points to the memory address of password. This RAX, 8. This helps in points to address of password. Like a password is stored somewhere in RAX. Okay, so it is pointing to that address. Now RAX is having the address, like this is in second hand side is inputted, like given into the first one. So RAX is in, so currently RAX is having our memory address, and RAX keyword, it will give what the word is present there, and the word which is present is our password. Okay, so password is then loaded into the memory. And then 4 is added to it. Like it points, it was earlier pointing here. Okay, now 4 is added to it. 1 2 3 4. That means it is comparing the 5th index. First one this, second is this, third is this, fourth is this, fifth is this. So it is comparing the at the 5th position. Means only the only you can security check, or the only comparisons over in this binary is, first one is length of the binary. Okay, not length. First one is checking the number of argument passed is 2. Then it is checking the length of the argument, and then it is checking whether the @ is present over 5th. And if these comparisons are satisfied, then it will proceed to this and we will get a flag. So let's change the 5th character with @. Copy it. /b. Nice job. See, so there can be multiple keys. if I change it to 44444, it will give me nice job, because the only checks were number of arguments, 2 arguments, length of the password should be 10, and at the 5th character there should be @present. Okay, so these were some approaches, some information about the tools. Okay. And yes, you can go with online tutorials, and yes, download this Gdb. About IDA, I will send a video later, because I have to install, this is my freshly installed Ubuntu, and I have to install Windows also. So I will do it and configure that also, and then I will send the video of IDA Pro. So till that, you can, there is one website known as crackme.one. Here there are many, this much number of questions for reversing itself. There are categories, difficulty level, language, which language you want to try, platform. Okay, so choose easy, very easy, C++, and Linux, Unix platform. Search. Here you will have your challenges. Solutions are also there. Okay, so simple crack me, just download this, find the key. Okay, let's try this one. CD download, unzip 5, and yes, the password of this will be crackmes.one. Password will be crackmes.one. This will be password. 7z file is extracted using 7zx crackme, and we have our crackme with this. Okay, first thing first, file crackme stripped. Okay, stripped and dynamically linked strings crackme. Very crap. Okay, entry key, good job, try again. /crackme, enter key, random, try again, ltrace /crackme. Okay, it is compared with this. Good job. Okay, but the task was find the key, find the Easter egg, and decrypt. Okay. This was our hash. We have to decrypt it, and we have decrypt MD5 hash. Paste, decrypt. What? MD5 decrypt. Start different website. decode, not having here also. Decrypt. Okay, found pass 1785. So okay, this is done. So at any case, like you are stuck, so you can just go to the solutions. You will have the solutions. You can download it, and you can see wherever you are stuck. So I will prefer you to understand assembly language first. Just have some assembly language tutorial, like just a basic things, just so that you can understand what add does, what sub does, move, and keyword, and d word, ptr, all those things what they do. Like there are many others also. So if you have a basic idea about these instructions, so you can be able to understand why the instruction assembly language itself, okay, that what process is happening over there, what execution or how the input is processed likewise. So I will highly recommend you to go through the assembly language first. Okay, there are many videos, you can go through them, then try solving this and develop as much as approaches you can. Play many CTFs. Okay, one more. Okay, I forgot to mention one thing. There is not keyboard. So not only binaries are given to you. Okay, you are having Python code also with you. Python reversing. Let's say I have a function 1. It does takes the input and it does XOR byte, or you can say character by character with 7, just an example. Okay, and it gives the output. And what you will be given with, you are given with the question will be like, you will be given Python code, and also you will be given with an output. Let's say you have an output A, B, C, D, E, F, or whatever it is. So output is given to you, the process is given to you. Now they will be asking you what was the flag, or you can say, or it would be like this, input flag. So the question will be like, the flag was given as an input, some processing has been done on it, and the output received is this, find the flag. So you have to go from the bottom to the top. So here okay, if you analyze the Python code, you will be getting to know that XOR is happening with character 7, and if you again XOR it with the same number, like if I XOR A with 10 with 7, whatever output I will get, let's say I get the output A, and if I XOR A again with 7, I will get the output as 10. So if you know this property, you can solve this. So questions not only comes in the binary format, it comes in the code format also. You are given the output, they can ask you the input, or vice versa. They will give you input, and function will be there, or process code will be there, but that code will in such a format that you will not be able to run it. You only know the processes, what instructions are being done, what process is being done on input, or how process is being manipulated, or input is manipulated. So likewise you have to calculate the output. So thank you, this was all about the reversing, and if you have any doubt, you can directly contact me. And yes, please go through the assembly language and this website crackers.one. Try to solve it, and I will give you the exe reversing also.